All right, this is problem 23 in section 11.1. And we have in Olympic curling, the scoring area consists of 4 concentric circles on the ice with radii of 6 inches, 2 feet, 4 feet, 6 feet. And then we want to know if a team member lands a stone randomly within the scoring area, we want to find the probability that it ends up centered on the given color. Okay, and then they're giving us these colors, and here's the picture. And in the picture in the book, they have this shaded nicely. So this is red, white, then this is blue, and the innermost circle there is white. Okay. All right, so the first thing is because we're given units here that are in, we're given measurements that are actually in different units, we need to change those into the same unit. And so I'm going to go ahead and just take feet, all of these into inches. And the reason that I'm wanting to do that is because we're really going to have to look at the area of each of these regions to be able to answer this question. Because of the fact that we're talking about something that is a circle and landing a particular object on a circle, then the area, the relationship between the areas is what will give us the probability. So let's start with just converting. We have the 6 inches, whoops. We have the 6 inches, that's already in inches. And then our 2 feet, that's obviously, and so what I'm doing here is, there's 12 inches in a foot. So if I'm just taking 12 inches, times the 2 feet, then we're going to get 24 inches there. Okay, and 4 feet, we're doing the same thing, so just multiplying by 12, and we have 48 inches, and 6 feet, multiplying by 12, and we have 72 inches there. All right, so let's go ahead and actually calculate the area for each of these in the circle. And if you remember the area formula for a circle is pi r squared. And so if I calculate, for instance, for the 6 inches, the area is going to be pi, and because these are all radii, that's what they're telling us, times the radius, so times 6 squared. Okay, so this is actually 36 pi. And for the 2 feet, the area is pi times the 24 squared. When you take 24 and square it, you get 576 pi. Okay, the 4 feet, so that's going to be pi times 48 squared. So square 48, and you're going to get 2304 pi. And the 6 feet, we get 72 squared, and that'll be 5184 pi. All right, so now that we have all of these areas, we know, for instance, what the area is of each of these regions right here. Okay, and what we have to think about is the fact that when we get, so for instance, the 6-inch radii is the small one right here. The area is actually giving us that whole area just right in there in that first circle. The second one, when we look at the 2 feet, the 2 foot radius, that's still going from the interior to, let me draw it here, from the interior out to the border of this second circle right here. So when we do the area for that, it actually includes this area right here and also this area in the blue. So even though the 6 inches, when we do that direct calculation, that 36 pi gives us the area of just the interior white circle, this one does not give us the blue. It gives us the blue and the white. So this blue and that white. And the 4 feet gives us the area of the blue, the white, or excuse me, the white, the blue, and then the white. And the 6 foot, the white, the blue, the white, and the red. Okay, so we're going to have to use that knowledge to be able to calculate the rest of this. All right, so in part A, they ask us to find the probability of landing on the red. Okay, so that was here. Okay, so we remember with probability, it's always desired over total. And if we look at our picture here, so the desired region that we want is the red region. Let's see if color will show up here. Oh yeah, kind of. So this is our red region, and that's the area that we're looking for. Okay, so we know that the radius that goes from the center out to here is 6 feet. And so if I were to take that 6 feet and subtract off the radius that goes from here to here, it would actually give me the area of just the red. Okay, so that would actually be the 5184 pi minus the 2304 pi. And that gives me, well, that's the top part. That's the desired. Remember, probability is always a fraction, desired over total. And so that's our desired, and we'll calculate that in a second. The total is just our 5184. That's the total area for the circle there. Okay, so in the top, when you do that subtraction, you get 2880 pi over 5184 pi, and the pi's are going to cancel. And if you go ahead and reduce this fraction, it will actually reduce down to 5/9. Okay, so that's the probability of the red. And the probability, part B, was the probability of the white. All right, so there's actually two regions that are white. And let me get the blue colored in here. So this is blue in there. And so there's two regions that are white. There's this interior circle and then this third circle out here. Okay, so when we calculate the desired, we're actually going to have to calculate both of those as our desired portion. Okay, so I'm going to just go ahead and say the interior. So this is the interior circle. That's the area of the interior circle is 36 pi. And obviously getting that from here, right here. Okay. And then we're going to need to add to that whatever the area is of all of this white. Well, that's going to be the difference between the area from here to here and then the area from here to here. Okay. So that would be the 2304 pi. So that's our area for the 4 foot, and subtracting off the 576 pi. Okay, and that's our top, and the bottom again is the 5184 pi. Okay, so if you do this calculation here in the top, you're going to end up with 1764 pi over our 5184 pi. Pi's cancel, and when you reduce that fraction, you're going to get 49 over 144. Okay. All right, and let's also look at the probability of the blue. So this is part C. And the probability of the blue, we're doing the same concept here. Okay, so, whoops. Probability of blue. Same concept. We're going to have to take the radius, the area from here to here, from the innermost to the out of the blue, and then subtract the white portion, the innermost white portion. Okay, so that is going to be, the desired is our 576 number, and then we're going to subtract our 36 pi number. That's our top, and the bottom is again the total. And when we do that calculation, we get 540 pi over the 5184 pi. Pi's cancel, and this reduces to 5 over 48. Okay, so that's it in that problem.